Hello, friends. Welcome to the channel where we explore some of the most fascinating questions about science, reality, and human perception. Today's topic sounds almost like a philosophical riddle, yet it is seriously discussed within the scientific community. Can the universe exist without an observer? Get comfortable, ahead is a conversation that might slightly change the way you look at reality. And let's clarify right away, in this video, we rely on scientific ideas and hypotheses, avoid sensational claims, and remember that many questions in modern physics are still open. Imagine absolute silence for a moment. No stars, no planets, no life, not a single being capable of seeing or measuring anything. A natural question arises: if no one observes the universe, is it still happening? Or is reality somehow connected to the fact that it can be detected? At first glance, the answer seems obvious. Of course, the universe existed for billions of years before humans appeared. But as physics has advanced, some aspects of this question have turned out to be less straightforward than once believed. To understand this, we need to begin with the concept of observation. In everyday life, to observe simply means to look. But in science, it means something more precise. Observation is any interaction through which information about a system becomes available for measurement. It doesn't have to involve a human with a telescope, it could be a detector, a sensor, or even one particle colliding with another. And this is where things start to get interesting. In the 20th century, quantum physics revealed that at the microscopic level, nature behaves very differently from what we are used to. Particles can display properties of both waves and matter. Their state is often described not by a single definite position, but by probabilities. One of the most famous experiments illustrating this is the double-slit experiment. When particles such as photons or electrons pass through narrow openings, they create an interference pattern typical of waves. But if scientists attempt to determine which slit a particle travels through, the pattern changes and the system behaves differently. It is important to emphasize, scientists do not believe that a human gaze magically creates reality. What matters is the physical interaction between a measuring device and the system. Still, the fact that measurement is linked to a change in quantum behavior has led researchers to think deeply about the role of observation in nature. This gave rise to what is often called the observer problem, one of the most discussed questions in fundamental physics. But does this mean the universe needs an observer in order to exist? Most scientists answer cautiously, probably not. The cosmos evolved long before life appeared on Earth. We detect light from distant galaxies that has traveled billions of years. The cosmic microwave background provides clues about the early universe. All of this suggests that cosmic processes unfolded independently of human presence. Yet quantum theory raises a more subtle question: what exactly do we mean by reality if a system's properties can depend on how they are measured? Some interpretations of quantum mechanics propose that before measurement, a system is described by multiple possible states. Measurement appears to select one outcome. But what counts as a measurement? Does it require a mind? Or is any physical interaction sufficient? There is no single agreed-upon answer, and several scientific approaches attempt to address this puzzle. For example, the theory of decoherence suggests that quantum systems constantly interact with their environments. These interactions rapidly suppress delicate quantum effects and make the world appear stable and predictable at the macroscopic scale. In this picture, no special observer is required, the universe is continuously interacting with itself. Other interpretations, such as the many worlds framework, propose an even more unusual idea: all possible outcomes of quantum events occur, but in different branches of reality. It may sound like science fiction, but it is important to remember that these are mathematical models designed to describe observed phenomena. Scientists continue to debate their strengths and limitations. There is also a more philosophical perspective. Perhaps the question, does the universe exist without an observer, is connected to how we define existence itself. In science, an object is generally considered to exist if its properties can be detected through interaction. And interactions are happening everywhere: stars emit light, particles collide, gravity shapes the motion of galaxies. In that sense, the universe is always observable, just not necessarily by humans. Sometimes this discussion leads to an even deeper question: why is there something rather than nothing? Science does not yet offer a final answer, but it provides models of the early universe, studies quantum fluctuations, and investigates the fundamental laws of nature. Interestingly, our very ability to ask these questions is itself a result of cosmic evolution. Matter formed stars, stars produced heavy elements, those elements helped form planets, and on at least one of those planets, life emerged, life capable of reflecting on the universe. You could say that through us, the universe has gained a way to observe itself. It's a poetic thought, often used as a metaphor rather than a strict scientific claim. Maintaining a balance between imagination and evidence is essential. Popular discussions of quantum physics sometimes create the impression that consciousness literally constructs reality. However, most researchers hold a more cautious view. Physical processes occur independently of human perception, even though our descriptions of those processes are always tied to measurement. This brings us to another intriguing idea: the limits of knowledge. We study the universe using instruments, theories, and mathematics. Yet every measurement has constraints. This is not a flaw in science, it is a natural part of discovery. With each decade, technology becomes more precise, and our understanding deepens. There was a time when humanity did not even know that galaxies existed beyond the Milky Way. Today, we observe structures billions of light-years away. Who knows what discoveries still lie ahead? Perhaps the question of the observer will one day be framed in an entirely new way. Another reason this topic is so captivating is that it sits at the boundary between physics and philosophy. Physics asks, what processes occur? Philosophy asks, what do they mean for our understanding of reality? Although their methods differ, both pursue a deeper comprehension of the world. Some of the most important scientific advances have begun with simple wonder. Why do the laws of nature exist at all? Why can they be described mathematically? Why does the universe allow complex structures to form? We do not yet have definitive answers, but we do have something just as valuable: the ability to explore. And perhaps the most reliable conclusion today is this: according to all available evidence, the universe does not depend on human presence. But observation allows it to become understandable. Without observers, reality would likely continue to unfold. Without investigation, we simply wouldn't know about it. There is a special beauty in that idea. Science not only provides answers, it expands the horizon of questions. Think about it, just over a century ago, quantum physics was only beginning to take shape. Today, it underlies technologies we use every day. This reminds us that even the most abstract ideas can eventually transform our understanding of the world. So, can the universe exist without an observer? Most scientific models suggest yes. Yet observation remains essential for turning events into knowledge. Perhaps the better question is not does the universe need an observer, but how does observation help us uncover its secrets? And the more we learn, the clearer it becomes we are only at the beginning of an immense journey. If topics like this resonate with you, consider supporting the video and sharing your thoughts in the comments. Do you think our understanding of reality will dramatically change in the future, or have we already discovered the most fundamental principles? Subscribe to the channel so you don't miss upcoming videos about science, consciousness, and the mysteries of the cosmos. There are many more ideas ahead that may inspire you to see the familiar world from a new perspective. Thank you for spending this time with us. And remember, curiosity is one of humanity's greatest driving forces. See you in the next video.